So let us continue our discussion. And in the last video, we were talking about how to convert this ER model into relational model. So we discussed about five entities. We discussed about employee, customer, loan, payment, branch. Now it's time to discuss about the final entity, which is account. Now, if you carefully observe, account is not a normal entity, right? It is a case of specialization, generalization or specialization. Here, if you are dividing a particular entity into two sub-entities, like savings account and current account. Now, you need to handle this case very specially. Let us discuss how do we handle it. So, we're talking about accounts, right? So, let us discuss our sixth entity, which is accounts. Now, in the case of generalization, you have three options. Let us discuss all of them. Like, let us discuss method one. So, first method is if you store all the things in one table. Let us say you store name, account number, then balance, interest, and charges in same table. Now, we discussed a lot of times that the drawback for this using this method is if account is a saving account, you'll be having these data in these four columns. And if a account is a current account, you'll be having data in these columns. So in either of the case, you're wasting one particular sale in each of the case, right? So this is waste of data and you cannot afford to waste this much space. So this is not feasible. So let us talk about our next method. Let's talk about method 2. Now imagine a case where you store two different tables for savings account and current account. Let us see how do we store that. Like if you have name, account number, balance, and interest in one account, one table, and then in the other table you have name, again balance, account number, and charges. Now are you able to see that the problem here is these three tables, like these three attributes are repeated. Now you are wasting space by writing them again and again. So instead of you went for saving this space of writing this thing, but you ended up like adding an extra space, right? So yeah, let us see what we have as our method 3. Let us discuss method 3 now. Now we discuss that if we store both the things in same table, it is not going to help because we are wasting one cell in each row. If we are storing both the things in two different tables, it is not going to help. Why? Because we are storing same attribute again and again. So it is again wasting space. So why can't we store account details in different table and savings account related things in different table and current account related things in different table? Let us see how do we do that. Let us say we have one table which is for accounts. So for accounts table, we'll be having name, account number, and balance, right? Now for other table which is for savings account, let us have one foreign key which is account number and interest, rate of interest. Then for current account, we'll be having account number and charges. So now what we are doing is we're just repeating this particular attribute only. We are repeating this attribute only. So we're saving a lot of space. We're not wasting space having an extra attribute for a generalized account kind of structure, and we are not even repeating the same thing again and again. So this is the most optimal approach which we can think of, and this is how it is done generally. Like this, we generally use this method to store tables or any kind of entities where generalization or specialization kind of thing occurs. Now, one more very important point to note is, now imagine a situation if you're using this particular case where you're storing name, account number, balance, interest in one table, and name, account number, balance, charges in another table. Now, this particular case is able to accommodate a case where only two accounts exist, which is savings and currents. Same is the case here. Like, what is this table able to accommodate? Only two accounts, which is savings and currents. Now, if you want to introduce one more account, one more type, let's say tomorrow you come up with one more type and you want to include that in your database, you need to add more columns, you need to change the structure for that. But in this case, you just simply add one more table and just link it with account number and whatever the field is. So it is much more easy to scale up, and it is much more easy to accommodate new things in this particular method. So this is one more reason why this is used. Now we're done with discussing about this ER model. We discussed in deeply about how do we represent all the relations, how do we represent all types of entities. Now it is time, let us understand one special case. Let us understand. Now see, we discussed about how do we have some relations, right? We introduce foreign key and then we try to establish relations among attributes. Like if we have relations that customer contacts employee. So we'll be having a foreign key of employee ID in the customer table, and it says that this customer is contacting this employee. We can have that, right? Now, what happens in this case? Like here we have manager manages employee manages employee. So manager is managing employee, right? But what are the two entities involved? There is only one entity involved here. So how do we handle this case? Let us discuss in detail. Now, let us talk about unary relationships. Like how do we specially talk about these things? Now, remember what used to happen is, if you are having a connection between two tables, let us say if you are having connection between employees and customers, you are using a primary key of one entity as a primary key for as a foreign key for other entity, right? So here, uh, you cannot use can you use primary key of the same entity as the foreign key? So this is what exactly you do. Let us understand how. Now we have employee table, right? What were the fields in employee table? Employee had employee ID, then name. Now address was composite attribute, so we decided to divide it. City, country, the then years of service not was not there. Joining date. Now these were the attributes for employee. Now to have a relationship between same employees, what we will do is we will ensure that we'll have one more entity, like it is going to be the same primary key of this table, but can we have two attributes of same name? No, right? So to avoid this, we'll be naming it as manager ID or any other name. Now we named it as manager ID just to avoid the confusion. Now let us say if we have 5 employees, like 1, 2, 3, 4, and 5. Now we have some data for each employee, right? Some name, some city, some data is there. Now let's say if 3 is manager and 3 is managing 1, 2, 4, and 5. So what we'll have is we'll have 3 as manager ID of 1, 3 as manager ID of 2, then for 3 we'll have null. Like 3 is itself a manager, so no need to, 3 is not having any other manager. This indicates that. And then we'll fill the table accordingly. Now what is happening is we established a relation between the same entity. Now if I want to know, hey, can you list me all the employees who are managers? So I'll just check all the employees where manager ID is null. Now if I want to know who are the employees managed by 3, so what I'll do is I'll check all the employees whose manager ID is 3. So this is how I'm establishing a relationship between the same entity. So we're done for now with relational models and all the examples. Let us talk about our next step, which is implementing relational model. Let us talk about our DBMS software. Let us understand what is MySQL in the next video.